Hey guys, this is going to be lesson 2, and I'm going to try to make it a shorter video than previous, but welcome back. Lesson 2 is going to be on what are stars and galaxies. Okay, I'll move my face over so you can see the picture it's supposed to move. There you go. All right. You see stars as tiny points of white light in the night sky, but stars are not tiny in the least bit, and they're not actually white. So this is something that I was very surprised at learning the first time I learned this many years ago, that stars, when we see them, we think they're these little bitty dots, but they're not. They're giant balls of gas. And they have, just like us, we have different life cycles. They have life cycles. So we're going to be learning about that and also what makes up a galaxy and the fact that we're in a galaxy. So, and I don't have my mouse, so we're going to, there we go. All right. All right. So, twinkling stars. That's not good. Okay, twinkling stars. People have always looked up at the sky. People use them to navigate in the ocean or the seas. People use them to navigate if they were ever lost or actually getting from point A to point B. Native Americans use them. But when we actually started to study them, okay, that was called astronomy. Okay? Astronomy is the study of objects in space and their characteristics. Now, it's objects, not just planets and stars. Any object. If you look up at the sky and see those stars and you're studying them, you're also studying the asteroids, meteors, comets, whatever. That's called astronomy. And if you happen to be doing that, you would be called an astronomer. So astronomy is the study of the object in space, and an astronomer is the person who actually does the studying. Now, astronomers use many different types of telescopes to observe objects in space, such as stars and planets. So an astronomer uses a telescope. Okay, that is their tool of choice. Now, a telescope, there are many different kinds. You can have the simple one like this that can be found in people's bedrooms, classrooms more frequently. Or you can have the higher end ones like this that can see much further and can, like if you see this remote right here, you can actually put in coordinates and it would find it. Or you could see this right here. This is a huge telescope. It's in Hawaii that actually sees great distances, far galaxies. They use this is what like the major astronomers use. This could be like astronomer training. You're a little better at it. And then this is what the high astronomers use to study the stars, far off planets, different galaxies. So telescopes can range from something little bitty to a huge building. All right. So what is a star actually? Okay. We'll just put it up here. A star is a huge ball of hot, glowing gases that produce their own heat and light. The sun is the star you've known most of your life. Okay, you know this star. I can show you a picture. You draw pictures when you draw the sun when you draw pictures of outside. Usually you draw it as a round, yellow, orangey ball. So you know what the sun is. It seems much larger than all the other stars, and there's a good reason. Because the sun, our sun, is the closest star to us. That's why it appears to be much larger. Just think about it this way. If you were at your desk and I was right in front of you, I look pretty large. But if you're at one end of the hallway and I'm at the other end of the hallway, I look smaller. Okay? So that's how the sun and the stars is. That's how they are. The closer the star is, the larger it looks. So, being that the sun is our closest star, it's much larger than the stars we see at night. Hopefully that makes sense. But the sun is our closest star to us. Okay? Now, like I said, stars have life cycles, and a star is born. Okay? This right here is called the Horsehead Nebula. Now, stars form when gravity causes gas and dust and particles to come together, like they pull together, just like this. It's kind of like energy pulls them together. Now, these particles are squeezed so tight together under great pressure. Now, if you remember, before we had this break, we talked about fossils, and they're formed under pressure too. So just think of it this way. Everything is packed really tight with pressure. So these stars, they start off as gas and dust, and they're pushed together under great pressure. Now, eventually, this energy is stored. Okay, the energy is stored in here because it can't be destroyed or created, so the energy is stored. And what happens is that energy is eventually released as heat and light. And that's what a star does. A star produces its own light and heat. So this is a nebula, and that is actually the birthplace of stars. Stars are formed in nebulas. Okay? So a star is born because dust and gases come together because of gravity, and they form a tightly packed object. And that object eventually becomes a star that releases its own heat and light. Okay. I'm sorry about moving this back and forth. Okay. So stars are classified with four things. Okay. Stars are classified by their color. There are many different colors of stars. It could be from anywhere from blue, orange, yellow, white, red. So there's a classification of colors. Temperature, how hot or cool a star is. Brightness, and size. So there are four ways to classify a star: color, temperature, brightness, and size. Okay? The actual color of a star can actually tell us about the temperature that the star has. Just think about just colors when we think about cartoons or something, when people talk about hot and cold. Usually when things are cold, they're more of a blue color. When things are warmer, they're more of a reddish orange color. So if we see a star at a different color, astronomers can say, hey, that star is this old, just by the color. Now, this little classification chart, it's called the HR diagram, or the Hertzsprung-Russell diagram. So basically what this does is it can tell astronomers about a star, its brightness, and its temperature. Now, as you can see right here, temperature starts off red, and as the temperature goes down, it turns more of a, you see, red, orange, yellow, white to blue. So when we're talking about temperatures, we know that the hottest stars are red, and the coolest stars are going to be your blue. Okay, so we have blue as your coolest, red as your warmest. You can see right here, if you look at your thing right here, you can say, okay, well then the supergiant is my hottest star. And then you have brightness. Brightness comes all the way from a white dwarf, which is not bright at all. You can barely see it, all the way up to the brightest, like a blue giant and a supergiant. So you can see already right now that giants are going to be your brightest stars. So this is actually a chart that astronomers use that most people refer to it as the HR chart because it's much easier than the Hertzsprung-Russell chart to say. But later on, like when you get to sixth grade and up, they'll use more of this stuff. But I just wanted to give you a preview of what that chart would look like. Now, so bright. Believe it or not, our sun is actually only average in size and brightness. It's not even out there. If we go back to this little chart, our sun is in the middle. So it's not big, and it's not really all that bright. So just imagine if we were near a larger, brighter star, how much warmer we would be. So compared to all the other stars in the sky, our sun is average. Now, the reason it looks so bright and so big is because it's closer to us on Earth. And just how close? Well, it's about 150 million kilometers, or 93 million miles. That's a lot of miles, okay? And instead of saying like 150 million kilometers or 93 million kilometers every time we measure something in space, scientists use that measurement, a distance from the sun to Earth, as a relative rule of thumb measurement. They call it an astronomical unit, or an AU. So 1 AU is the distance from the sun to Earth. That's 1 AU. So whenever you hear somebody say, oh, that's 1 AU, well, we can go back and think, okay, well, that's the distance from the sun to the Earth. It's kind of like when we say that's 1 yard. Well, in my head, I can go ahead and think, oh, well, a yard is 3 feet. Okay, I can picture that. So it's a much easier unit of measurement when we talk about great distances, because when we talk about space, it's just not like from your neighbor to you or from your house to Walmart. It's a big distance apart. Okay, what exactly, or how exactly does the light from a star get to us? Well, it's called, when you hear light years, when you think about light years, you think about time. When I first saw it, like when I was younger, I said, oh, well, light years is time. It's not. Light years is actually a distance. Light year, or light years, is the distance that light travels in 1 year. So 1 light year is equal to 9.5 trillion kilometers. That's a lot. That's a trillion. So however long in light years it takes for a star's light to reach Earth, that's how we can say like how far away it is. So if you look over here, this is speed of light. That's how light travels. And we're into seconds. So the moon is not as far away as other things are to Earth. So like it takes 1.3 light seconds for the light from there to travel to Earth. It takes 8 light minutes for the sun's light to get to Earth. Now Mars, it's about 12.7 light minutes. And then we start getting into years. Alpha Centauri is, I could be mistaken here, I think it's the second closest star to us. I'll have to look. But it takes 4.4 light years for that star's light to get to Earth. And believe it or not, sometimes when we have a star, the light actually reaches us, that star may actually not be there anymore. That's how far away it is. So just because you're seeing the star light up in the sky twinkling, that does not mean that the star is still there. That just means how the light, we're just now seeing it. That's how far away it is. And Earth to the far side of the Milky Way Galaxy is 52,000 light years. And we're going to talk about the Milky Way Galaxy here in a minute. But basically, all you need to know is that a light year is distance, not time. It's the distance it takes for a star's light that it gives off to reach Earth. Okay? So the further away, the longer it's going to take. All right, here we go. Milky Way Galaxy, going galactical. So we are in the Milky Way Galaxy. Okay? Our solar system is part of a Milky Way Galaxy. And if you look right here, and we'll talk about this in a minute, we're actually in a spiral galaxy. You can see it's spiraling right there. And we're actually in the far corner right here. That's just us. So you can only imagine what's in these other little spiral ends. But our solar system is huge, yet it is only part of a larger system. Okay? Now, our sun is surrounded. Okay? It's one of many groups of stars. All right? So, believe it or not, there's billions of stars other than our star, the sun, in our galaxy, which is called the Milky Way Galaxy. Okay? A galaxy is a group of billions of stars, objects that orbit those stars, gas, and dust. That's what a galaxy is. And how is this big galaxy held together? Well, by gravity. And we've talked about gravitational forces before when we talked about like things falling down and coming back together and forces. So we are in the Milky Way Galaxy, and this is where we're at. So we're just a little bitty, kind of like, if you think about it as like a bag of rice, we're one little grain of rice in a big bag. So you can only imagine what other planets, stars, and whatever else is out here. Okay, there are 4 different types of galaxies. 4 different types. I'll move my picture over here so you can see better. Now, I'm sorry. I apologize. Okay, so as you can tell, this is the last slide. The spiral is one that is probably the easiest to tell because it is spiraling. It's kind of like almost if you were to have a wet tennis ball and you threw the tennis ball, you could see all the water going like that. A spiral has several little arms that are going in the directions. So that's a spiral. We are part of a spiral galaxy. Now, a barred spiral, okay, it's different. It is like, if you can see right here, you have your middle galaxy, but it only has 2 arms. It's kind of like makes a backwards S if you're looking at it. So that's a barred spiral galaxy. A regular spiral galaxy has several arms that are coming out of it. A barred only has 2. Now, an irregular galaxy, it kind of just looks like you threw paint up against the wall. It's just everywhere. It has no definite shape. And then we have an elliptical, which basically, if you can look, looks like an oval. It's very bright in the center, and it goes out like an egg. So there are 4 types of galaxies. You have spiral, barred spiral, irregular, and elliptical. Now, that is the end of lesson 2. If you would like, and I do appreciate the kids who went back and did the quiz for lesson 1. Thank you very much. Lesson 2 also has a quiz. Now remember, I do not mind if you go back and use the PowerPoint as you're taking the quiz to help you out. That just tells me you know how to go back and look for information. Now I appreciate everyone who listened, paid attention, and I hope to see you soon.